Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And you work hard to make sure that your data is reliable and accurate, but can you say the same about the deployment of your machine learning models? The Scafos platform from Metis Machine was built to give your data scientists the end-to-end support that they need throughout the machine learning lifecycle. Scafos maximizes interoperability with your existing tools and platforms and offers real-time insights and the ability to be up and running with cloud-based production-scale infrastructure instantaneously. Request a demo today at dataengineeringpodcast.com/metis-machine to learn more about how Metis Machine is operationalizing data science. And if you're attending the Strata Data Conference in New York in September, then come say hi to Metis Machine at booth P16. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And join the discussion at dataengineeringpodcast.com/chat. Your host is Tobias Macy, and today I'm interviewing Pete Cheslock and Thomas Hazel about Chaos Search and their effort to bring historical depth to your Elasticsearch data. So, Pete, could you start by introducing yourself?
Yeah, I am Pete Cheslock, and I'm currently the VP of Products for Chaos Search.
And Thomas, how about yourself?
Yeah, Thomas Hazel, founder, CTO, inventor of the unique technology we use, as well as the idea.
And going back to you, Pete, can you share how you first got involved in the area of data management?
Yeah, so just getting involved in kind of managing large-scale systems on Amazon, kind of back in 2009, I actually worked for an email archiving company, and we were storing petabytes of data on S3 when probably you shouldn't be storing that amount of data at that age in the early days of S3. But what's interesting is kind of every company I've been at since then has seen just the data explode, right? And having to build and run databases to manage that, like Cassandra, Elasticsearch, Postgres, and then the overhead and the mental overhead that you have to deal with managing that data. So I come from this role is interesting for me at Chaos Search, being kind of the head of product, in that my history has been actually just in the running of the systems to deliver data for customers. Being on the other side of it, it's like I now can help drive helping customers with their data problems.
And Thomas, how about yourself? Do you remember how you first got involved in the area of data management?
Well, so I come from a background of distributed systems from my telecom days and the last 50 years building database and really going after some of the information theory problems of like text search or column stores or big data analytics. And so what I wanted to do was solve some of the cost complexity, and I had an idea with respect to a new data format that I thought could solve these scale problems that Pete just mentioned.
And so, given that, can you discuss a bit about what it is that you've built at Chaos Search and the original problems that you were trying to solve when you started building that technology and the company around it?
Yeah, sure. So we call this technology Data Edge. Like I mentioned, it's a new file format that supports both text search and relational queries. And if you're familiar with Elasticsearch as a platform or a variety of others, it uses this technology, this indexing technology called Lucene, and it's great for text search. However, it can explode your data size, meaning that the raw source that you store can go up to 5x the size because of the underlying inverted index technology. I wanted to go off and solve that, but I also wanted to solve not just the reducing of the size of the data, but the ability to do it in a distributed way, and do it in object storage, in this case, Amazon S3, because S3 was cost effective. You can store terabytes of data for very little amount of money. It's elastic, it's simple, and create a data fabric around S3 with this indexing technology, and ultimately allow you to provide analytics on your storage directly.
And in the documentation and the website for your product, a lot of the focus is on the idea of log data. But when going through the other documentation, it looks like you also support different file types or formats. So I'm curious if you can discuss a bit about what types of data you're focused on supporting and what your reasoning was for focusing on those areas to begin with.
Yeah, so from my perspective, the initial kind of use case that we want to support with this technology is kind of the log and event management, and the main reason is that the problem is just so vast in that space. If you rewind back about, I think it's 9 years at this point, when Elasticsearch first came out, I was very lucky working for a company that got to start using that at a very early stage, and we were storing our email platform, our email discovery platform was in there. And in that scenario, Lucene made a ton of sense for that because the raw data in those emails was actually reduced on the index side. As Elasticsearch evolved into a business and brought on other open source tools like Kibana and Logstash, you saw this huge explosion in the usage of Elasticsearch for log data. And it's almost comical that it was used for like highly structured log data like JSON logging. And like what Thomas was saying before is you're putting in these JSON logs and the inverted index is causing them to explode up dramatically in size. So now you're managing significantly more data on these clusters. Now I love Elasticsearch and I've been using it for a long time. The APIs are great and scaling it is relatively easy from a technology perspective, but the challenge really is that the cost of it, right? After a while, you're running hundreds of Elasticsearch servers, potentially spending, in the Amazon world or any cloud world, right? You're paying for every bit of storage on there. And so you enter in this scenario of saying to yourself, well, maybe I'm going to drop this data instead of keeping it around. And I think when the founders here at Chaos Search was looking at this market, too many people were saying to themselves, I can't keep the long tail of data. I need to throw it away. I can only save 7 days of data. And what's amazing, I think, in my perspective, is that what this technology really has done is enable the long tail so that you don't have to make that choice anymore. Do I keep my data or do I throw it away? Because it can be saved and queryable on Elasticsearch or on S3 via this new file format for so much longer.
Yeah, and I'll add to that real quick is the basis of using object storage to store your long tail. And then with our service, enabling you to do the same tooling, the same Elastic API, Kibana interface, even with Logstash, the ability to dump into S3, really that was the value that customers love. They just couldn't do it from a long perspective because it was cost prohibitive. And we're offering a service at a price point that, weeks, months, years of data retention and analytics is where we're going in on the market.
And also from the Elasticsearch perspective, as you're increasing the amount of storage that you're retaining to be able to have longer views of that log or metric data, it increases the operational overhead of being able to manage these larger clusters, either in terms of number of instances or just the overall volume of data and some of the complexities that go into the different shards for the indices and keeping them active and in memory. So on that point, I'm wondering if you can talk a bit more about some of the challenges that are inherent to having a larger scale Elasticsearch infrastructure for being able to manage those larger volumes or longer histories of data.
Yeah, absolutely. I mean, the great thing about Elasticsearch, like I said before, is that operationally, at least for a database, it's very friendly. It's got fantastic APIs. It's RESTful. It's got tons of metrics, tons of real-time ability to tune it, to update it. And the problem that the company Elastic is trying to solve is incredibly hard, and they're doing a very good job of it. The biggest problem, though, that you really run into is when you build out these Elasticsearch clusters and store the data, again, on one side, this explosion of Lucene in the size of your data. And the other trick too is because storage and compute are so tightly coupled, that's usually your scale point. So like one example is at a previous company, we used to run, like I think it was like the R3 or the R type where it's a decent sized memory, but then we have to attach EBS volumes to get the storage for that. So it's like you run a certain number of servers to support the memory and CPU requirements of ingest, and then you have to run a certain amount of disk to support kind of the storage of that data. And at a previous company, we tried a ton of things around tiering our Elasticsearch, where maybe we would take this large ingest of data onto really hot NVMe or SSDs, and then every day we would move indices over to like hard drives or a lower tiered storage. And it's kind of the fundamental problem of Elasticsearch in general, which is if I'm using Elasticsearch to store 30 or 90 days, or if I'm in some sort of compliance mode for even longer, I have to build that infrastructure to support both the real-time ingest and millisecond query, but do I really need a millisecond query for something that happened, 6 months ago or 8 months ago? Or can I even afford to keep that event from 8 months ago because I have to spend so much money on that storage? So
yeah, and we talked about how we want to solve the Lucene problem, but we also built out an architecture, as we mentioned, a data fabric up in Amazon around S3. And so we really decoupled storage and compute, and the storage being only S3, no SSDs or HDDs to back this solution, and that allows us to scale and use any aspect of compute, whether it's indexing, whether it's the queries itself, to elastically scale out without having to physically tie that storage, that capacity of that compute to one instance of a node. And so that allows us to dramatically reduce cost as well as scale elastically.
In terms of the infrastructure necessary for somebody who's using Chaos Search for being able to access that data in S3, is there actually any requirement for having an Elasticsearch cluster at all if they don't need these sub-second query responses?
Yeah, so that's a great question. As we talk to customers, the stage of the company we're at now, finding and refining the product for kind of real user use cases, the concept has always been this hypothesis of, well, we'll enable the long tail of data. And so we've talked to some customers that have said, well, I want to store a week's worth of data hot in my Elasticsearch cluster because I have lots of queries that I need really short time, within that millisecond range. And then over the, more recently, we've talked with companies that are dealing with such data challenges and a wealth of data coming in that when they make queries against the cluster, it actually causes some of the Elasticsearch hosts to reach out of memory conditions or affect the ingest of the data. And so in the conversations we've had with those customers, they've said things like, listen, a query that takes, one customer was just like, hey, if the query finishes, we'd be happy. And we're like, well, we're aiming for queries to finish in around maybe 10 seconds. And they were like, oh, well, as long as it finishes, we'll be really happy with that one. Right. And then on the other side, it really comes down to data ingest, right? So when you're shoving data into Elasticsearch, it can be available for search within, whatever your refresh rate is on Elasticsearch, and that's configurable. Maybe it's 1 second or 30 seconds, but it takes a lot of, processing power to reach that level. Since we're trying to enable kind of that long tail, it's really a question of how quickly could a thing be searchable when it lands in S3. And from our perspective, we're trying to build for like maybe 5 or 10 minutes or something like that. Again, trying to aim for the long tail. But what we found, and kind of answer your question, is that for some companies, for some people, a 5-minute delay in that log data is actually totally fine for them, right? It meets their requirements because they're saying to themselves, it's just so much data. I don't actually need a millisecond query and to get it back for this amount.
And one cool thing about our solution, it's on your S3, meaning that you don't move the data out of S3 and to put into another logging system or into your manual L configuration. It's your S3. You provide a read-only IAM role access, and you're up and running. We store our indices in your account, so you own all the data. You just provide a right location so we can store that. And all queries, all of that scale is on these indices, on your data account, where we provide the compute and the scale.
Yeah, that's actually a really good point that we didn't touch on before, which is, it's your data, right? Your data, your rules. We'll read the data from your bucket. We'll give you the compressed indices back in your bucket. And then the beauty is you can keep it for as long as you really want to keep it. You don't have to make that choice of, do I keep it in my Elasticsearch cluster? Or do I throw it away? You can just let it live for, whatever time you need.
And some of our customers are actually moving their raw data to Glacier for cheaper storage using our indices as the representation. So there's a lot of combinations that come out of a solution like ours. But the idea is that, as Pete mentioned, it's your data, it's your rules.
One question I have there in terms of you're running the queries against the data in S3 that is owned by the customer is that in some cases, there might be some concerns in terms of leakage of private data or anything like that to any third party. So I'm curious how you mitigate that in terms of running the compute against their data.
Yeah, absolutely. I mean, it's always going to be a question, and especially in this day and age, really any SaaS company, if you're not building kind of a security first model, you're going to find that your future is going to be very painful, right? And in a lot of cases, companies go down the laundry list of making sure that they, are in compliance with things like PCI, HIPAA, SOC 2, now GDPR being a big deal. What was really amazing about the way that this architecture was built is with that kind of security first model, which is that ability to not only have things like per customer encryption keys. We're even talking with some companies in the healthcare space where they can bring their own encryption key and ensure that the data is really fully under their control, much like how KMS can do with Amazon. In addition, for customers and their compute, they're essentially running their own environment of processes linked together with an encrypted network, again, with its own keys. So from a data handling perspective, coming from a security company who had to live through SOC 2 compliance and stuff, I actually am incredibly looking forward as we grow and go through those various audits. I think it'll be really refreshing to experience that from this architecture design.
And for loading the data into S3, I know that Elasticsearch, for instance, has the capacity for backing up indices to S3 directly from the cluster. And then there are also systems such as Logstash or FluentD that let you push your data directly to S3 from those systems. So I'm wondering, for somebody who's getting set up with Chaos Search, what's the preferred mechanism for being able to load that data into S3 and making it accessible to Chaos Search? And what are some of the considerations in terms of format or structure for that data to allow it to be indexable by the product that you're building?
Yeah, so it's another really good question. When I was doing kind of my due diligence into the company, to come on board and really trying to think about the problem they were solving, one of the things I said to Thomas, I said, hey, Elasticsearch has this ability to push an index up to S3, and that's Lucene. It's got a defined schema that we should be able to read, right? Like, could we just, ingest, for lack of a better term, these Lucene indexes as they're aged out of a hot cluster? And his response was, yeah, it's just another data type, right? And so that's really, I think, the mindset that we're trying to take, which is, there's a lot of companies who already have data in S3 because Amazon is very nice and lets you log really for a lot of their services right into S3. They have things like Kinesis Firehose where you can just stream data into S3. So obviously they've really optimized for that. And like you said, FluentD and Logstash and these other tools that can stream data to S3. The nice thing from our perspective is that we don't really care what the data is. Again, it's just another data type. But as an early stage company, the data types we're most interested in working with right now are things like CSVs, JSON, kind of a standard logging format. If you think like Apache logs, Nginx logs, things like that, Lucene indexes, stuff like that. As time goes on, supporting more and more data types is something that is pretty exciting with some of the schema type things that we can do on read.
Yeah, some of our benefits that we provide, obviously, reading in the Lucene index schema and the data. Parquet, which is a common format that is used. We add in a whole additional functionality that, say, Athena doesn't even have, particularly with full text search. Obviously, the visualization of Kibana. So there's a lot of data sources that we intend to add to our product line, and we're excited to include them.
And your mention of Athena brings me to my next question of what's the benefit of using something like Chaos Search with the Elasticsearch interface and the Kibana UI versus some of the other tooling that's been built on top of being able to access data directly from S3 and other stores, such as Presto and the Athena that's been built on top of it, or the Apache Drill project, or other things along those lines?
Yeah, I would say that's a good question. We get that often. There's a couple aspects to our product offering that is unique. One, we provide data management around S3, so data cataloging that's published in the Elastic API, Elastic Indices, as well as this concept called virtual folders where you can create object groupings that will filter out different aspects of your bucket. So that's one thing that Athena does not have. The other thing is all the text search and visualization that people have gotten to know and love. And then the price. To scan 1 terabyte of data, it's either $1 to $5. We have a significantly lower price, both from an Elastic's perspective as well as Athena perspective. I'll use Pete to talk about pricing if we want to get into that. But what we want to do is the ease of raw data to these Elastic indices quickly, as well as a price point that really hasn't been seen in the market.
Yeah, that's always been the challenge of logging companies is, the longer you store for a lot of logging companies, they're using Elasticsearch under the hood is, kind of one of the first problems. It's hard to scale that cost effectively just on your own. But then if you add on top of it, they have to essentially, charge up front for you. Maybe you don't even store that data for longer than 14 days, but they have to charge you up front for that because you could potentially. And that's why you see companies like Splunk so wildly successful because it's a great product. Don't get me wrong, but it's also incredibly expensive because of the challenge they're trying to solve for.
And what we've heard with people that have used Athena, it gets pricey very quickly. Even if you have your data formats in Parquet, it does make it a little bit smaller and performant. However, every query, every result set increases your storage size. We do late materialization, so there's no increased size per our query. And we've heard, stories of Athena's bill getting pretty high. It's a wonderful tool, but it's missing the text search as well as the Kibana Elastic capability.
S3 in particular has become somewhat of a de facto standard in terms of the API that they've built around it that other platforms have adopted to allow for easier interoperability. And I'm wondering if you either currently or have any plans to support using alternate object storage systems just using their S3 compatibility layer, such as what's been done with the OpenStack Swift project, or things like I think Backblaze has an S3 API.
No, you're right on. We made two bets. We made a bet on object storage S3 as a de facto API standard, as well as Elastic. We actually export through our data fabric the S3 API. You can either use Amazon's interface or ours. It's a pass-through for a lot of the functionality that they provide already. But we've extended it, like I mentioned, the data cataloging, data discovery, the virtual folders. We've extended the experience, but to your point, there's great products out there that have an S3 compliant API. Minio, an open source product, runs on Azure and Google. So we're actually excited about using object storage, and particularly the S3 interface, because we think it has a lot of legs.
Yeah, if you kind of think of it like Kubernetes has become the de facto API for deploying applications across multiple clouds, kind of look at what we're building as, the underlying object store we're talking to really shouldn't matter. And our goal is to try to put compute as close to those object stores as possible. Because what we're going to see over the next 3-5 years with Kubernetes and all of these hosted Kubernetes solutions on these cloud providers is more companies actually running multiple vendors, right? Multiple cloud vendors, because it's now so much easier, right? They're going to be putting data in these object stores because of the cost perspective. So, from our mindset, trying to be as close to that as possible is I think always a key.
And what we've done is we've really made object storage our fundamental architectural choice over distributed Akka Scala framework with our data edge indices. We really believe that we're planning for the future where, object storage is really core. As you, I'm sure, know, SSDs and HDDs have been core to databases for a long time, but they're not as flexible and not as elastic and as cheap as object storage has become and will continue to become.
Yeah, the whole logging world, I think the joke there is like the death of logging is yet to come. At the end of the day, as much as people are moving to things like, tracing or advanced time series metrics or, any sort of that type of ways of kind of monitoring their applications, at the end of the day, logs are still the best way to kind of slice and dice on structured data coming from applications and sometimes unstructured data. And so I've yet to see a company who has basically not used logs as part of their kind of troubleshooting, and it just seems like it's going to keep continuing to grow as more and more microservices. Yeah, right.
Example.
It's a great way, and there's a lot of people I think trying to solve like that problem of how do you monitor these microservices. But at the end of the day, there's still going to be a lot of data kind of being generated, and that's the thing I don't think anyone really is solving right now is how do you enable that long tail of data. And coming from a security company, I got excited because it's like if there's a new vulnerability that comes out and I can go back to every web request log I have for the last year and see like, hey, like what vulnerable endpoint did someone hit and what IPs did they hit it from? I mean, there's a real power to that you just really can't do nowadays without if you are lucky enough to have that data in S3, it's like, okay, like load up an EMR job and like process that in, or do it all the data processing in real time versus I just want to ask the question and get an answer.
And that's really why I wanted to create Chaos Search and this technology underneath. I wanted to make data and information as small as possible, as cost efficient, and as well as the value, the querying of that data. And it enables all these things that we hear customers time and time again talk about, and the cost prohibitive nature of storing that data over the long tail, as well as the margins that something like a Lucene technology has caused logging companies to really discourage data over weeks, months, let alone years.
And one of the things that you touched on there in terms of metrics puts me in mind of the work that Elastic has been focusing on with their Beats technologies of being able to ship things like system metrics and heartbeat results. And I'm curious what kind of support you have for being able to query those types of events and that type of data and use the same types of dashboards that are being built for some of the newer releases of Kibana for being able to use it as somewhat of a replacement or supplement to things like Datadog or New Relic.
Yeah, I mean, I think the goal of high cardinality metrics is something that a lot of companies are trying to solve. I think it's what everyone wants. That ability to slice and dice on like every customer and every request to every single endpoint. It's a supremely hard challenge that everyone's trying to solve in obviously different ways. One of the things that we were having kind of an internal discussion around time series metrics and stuff, and I had spoken of my past of building out graphite clusters and having a lot of fun doing that kind of stuff. And one of the responses was, oh, well, we'll probably just use Data Edge for that, and that's how we'll monitor it, basically like in a very meta way of we'll use this technology to monitor this technology, which I thought was pretty awesome.
And going back to the topic of space savings, and you mentioned that you have your own indexing strategy and format. So I'm curious, what are some of the mechanisms that you're using to allow for such drastic space savings of the data indexed into S3 versus what's present when it's hot in an Elasticsearch cluster and using that Lucene format?
Well, so quick question. The Lucene is an inverted index, so it has some power, but it actually has some cost where it points to all the symbols and all the documents, and it does increase the size. With our technology, and we have 3 pending patents on this because we think it's so important. I'll go at a high level, just because of some of the secret sauce we used to enable this. But the idea was we didn't use a ComSort technology or row or text. We really came up with a kind of insight I had with respect to information and locality. And with this insight, I had the ability to compress the data. Actually, I can even take compression algorithms like Snappy, which is from Google. It's very fast, but doesn't compress very well. I can take Snappy with our representation of the information and actually get a 2 to 3x reduction over what Snappy can traditionally do. So I'll leave it there, and I don't want to get too much into the weeds, let alone the tech. But this is something that maybe even someday in the future we'll open source it. But for now, we're keeping it inside the service.
Fair enough. And talking about the compute layer, I'm curious if you can discuss a bit about the overall system architecture and the life cycle of the data as it gets run through a query that somebody submits into the Chaos Search platform.
Yeah, sure. So as we mentioned, we have an indexing technology. We use S3 as a backing store and EC2 in Amazon for our compute. We have a Scala Akka distributed framework. For those listeners, it's really relatively popular distributed framework. I like to say it makes hard problems easy and easy problems hard. But it really solves the hard problems. And in distributed architecture, distributed frameworks, that's really where we want to focus. And Scala is even a fun language if you've ever played with it. So that's kind of our core framework. Data Edge as indices is streamed through this. So from an experience perspective, what we do is when you say through the API or the UI, index these resources in S3, we read that data, and through workers, through Akka workers, we spin up work on compute local to your bucket. So wherever your buckets are, the compute gets executed to minimize performance and cost. And that way, we actually are indexing data roughly 10x faster than Elastic can, and then write these representations into your S3 location you specified for us. From there, when a Elastic query, and we publish these indices, these named indices that you have indexed through Elastic API. So when Kibana or Elastic queries our system, it queries us over the Akka HTTP request. We have identified the indices, and we know the topology of this indices within this S3 indices within your S3 account. From there, we query these indices, and we materialize the results just like an Elastic API would, but we do it at a scale and price point that is quite unique. We also have Fabric underneath the hood that we spin up compute. We always have reserve compute so that a query plan always has resources because maybe it needs one worker, maybe it needs 10, maybe it needs 100. But that way we can spin up the queries to make them fast without having to, as Pete mentioned, blow up your cluster because you've overcommitted the request to the resources you backed.
And for systems such as one of the things that I'm using at my work is ElastAlert or other things that are relying directly on the Elasticsearch API, they can just run directly against Chaos Search for being able to run those same sorts of operations?
Yeah, absolutely. I mean, that's kind of the ultimate long-term goal is, to maybe we're never at full feature parity to an Elasticsearch cluster because obviously that's designed for, high throughput, low TTL, responses. But, there's definitely no reason that being able to expose those similar APIs, we really expect them to be used kind of in a similar way that customers would. What I think is most interesting is for, there's a lot of tools out there, especially as things like TensorFlow and a lot of these, ML type projects are becoming more mature in the open source world. Really, I think it'll enable tools like that to tie into these APIs as well. Which we're pretty excited about because now you can go to companies who previously could never afford to run ML models across a year's worth of data. Now they can do it for, arguably pennies on the dollar.
Yeah, and actually I'll add to that. One thing that we haven't addressed is, as I mentioned, this file format supports text and relational functionality, but its uniquely representation works nicely with Tensor and TensorFlow integration. So that's something that, Pete's here, he's our product guy, but our roadmap has TensorFlow integration as something that we've heard our customers are looking for.
And do you have any additional capabilities beyond what the Elastic API supports that you're exposing through Chaos Search for being able to leverage some of those relational aspects or simplify certain types of operations that might not necessarily be executed directly against an Elasticsearch cluster, but would be useful for some of these more long views of the data?
Yeah, I'm actually glad that you mentioned that. We actually have a data refinery that you can take your indices that you've created through the Chaos Search process and join them to create new indices, something that is missing in the Elastic search functionality to be able to denormalize that data set. Well, with us, we can actually virtually join the data to create new indices that you can use all the same toolings. That's something that is really cool to our product as well as important from what customers said. I want to have this correlate against that, where today it's hard to do. We've also have what we call 3QL API, which in essence is a S3-like query language. So a lot of the relational functionality can be queried through an S3 look and feel. Now, this is something that we love because we love S3. We love its simplicity. And for folks that want to query in an S3-like fashion, we have a language for that. But obviously, Elasticsearch API is a wonderful API, and we support that. But the refinery is where we marry all these unique data sets in a relational way that folks in today can't just do.
Yeah, I mean, the data science world, I think there was a research article or something that said that, data scientists spend like 90%, 80% of their time just kind of cleaning up the data sets. And so having this location where you can go through and make adjustments to the schema like on the fly, going through, there is a concept of this automated schema detection, but it's a data science a person going into the data might have different beliefs on how things should be represented. But that the concept that Thomas was talking about of the relational aspect of joining and correlating and making that much easier, I think is pretty awesome too.
And in terms of the query latency and the overall latencies in terms of interfacing with S3 and just trying to reduce the overall time budget for the system, both in terms of indexing and querying. I'm curious what you found to be some of the biggest contributors to that latency and some of the strategies that you're using to mitigate that.
Yeah, no, great question. And this is really where we spent a lot of our time over the last several years is query optimization, query planning via this data edge indexing. And so S3 has its limits, although ironically, every year seems like they're increasing those limits and the amount of data to be queried. So the idea is that you always query these indices that are stored in your S3 account because of our compression ratio and because of our unique way to scope and plan against the requests that you have. S3 has a limiting factor. So far at our scale testing in the terabytes has not been an issue at all. So we are really in the less than 10-second type queries for huge queries of aggregation to seconds to subseconds for quick finds, text search across gigs if not terabytes of data. So right now for what the use case in the long tail, it's been really I'll say happily surprised. We knew what we were doing. We knew S3 could achieve these goals. But so far, we've been really pleased, and we really betting that object storage is going to get cheaper, faster, and with our technology, with our architecture, and the use cases that we're going after, it seems to be a good marriage.
And one of the other issues with storing and accessing these large volumes of data is the question of permissions and access control, which has generally been fairly lacking in the Elastic product unless you're using their paid services or their XPack products. So I'm curious what types of controls you're exposing in your platform to help facilitate some of those security concerns.
Yeah, so I mean, at a high level, there's definitely some ways currently to break out in a general way of kind of restricting access down to who's able to see which things. One of the things that I'm most excited about is and something we're actively doing and reaching out and trying to find people that have these interesting security challenges and really get feedback from them on what are the kind of interesting features they want to see, whether it's being able to restrict down read write at the indice level, in different areas within the product or at the bucket or the data level. The nice thing is that there's a lot of ways to slice and dice the data within the product, and so that then gives people the ability to then potentially control within those kind of virtual buckets that get created when you slice and dice.
And one thing that we've seen our customers, they've been slicing it via the storage access. So how they create the roll-on access to a particular user is one level of access they provided, as well as field level access that you mentioned, like Elastic has with XPack. That's something that we are integrating with our product, is that when you create an object grouping or this virtual folder I mentioned, you can specify what fields you want to have access to, and we won't index it or we won't provide that access to that particular user. So this is something that we hear all aspects of security, but we have Pete Cheslock here who knows security and knows products. So I'll look to him to direct us navigate through those use cases.
And so given the fact that this product unlocks a fairly large amount of data that most people have generally not really had access to for such long time spans, I'm curious what you have found to be some of the most interesting or unexpected uses of the Chaos Search platform for being able to interact with and analyze all of that information.
Well, it's a really good question because we see that people come to our site, come to talk to us because of their classic long tail logged event requirements. So for instance, I got a fault or I got an alert. I know that it happened, but I don't know why. So they want to use Chaos Search to go search why and where and how did it happen. But then once they have this long tail, it's funny. The product team over at those companies go, well, now that I have this data, a lot of the times it's for internal use, but more often than not, we're hearing they want to provide that data back to the customers. And so these companies are looking at whole new product offerings from what they originally thought this data could provide. And so that's not saying a surprise, but it's been a happy trend. And then lastly, because we have that long trail, and this is a little bit further out for more the advanced users, is the analysis, the machine learning, the predictive analysis. Now, it's something that we hear that they want to do, but really the access of this data to their customers is really what we want to see. And, we'll see where it goes. Maybe new products are built around Chaos Search that haven't been seen before in the market.
Yeah, I think what's interesting from my perspective is, there's a lot of data already out there that exists today, that exists in Elasticsearch or other, logging type systems. But there's actually even more data. And the question is how much data there is that is essentially the data that's thrown away. And I've chatted when I was kind of diving into this company over the last few months, really thinking about if this was a group and a product that I wanted to get involved with. And I started chatting with a few of my friends on this. The answer that I got from a lot of them was, if I could do something with this data, I would keep it, but I can't. So I just throw it away. Or, I was thinking about getting my data science people to dive into this large data set. But at this point, it's like, I don't even know what database to put it into. I don't know how they would even access it. And so it's just kind of sitting there right now. So I think, that's kind of my hypothesis is that there is this large amount of data that is either exists and is not being used or is just being thrown away. And I think people are going to say to themselves, wow, it's so cheap for me to process this. I wonder what's there. And like Thomas was saying, that ability to say, let's actually monetize this data, from a product standpoint. I know there's a lot of people out there that would probably have some ideas if they could just do it, in a way that doesn't cost them a fortune.
And I imagine too that it would lend itself well to more useful and more accurate anomaly detection algorithms, where a number of the layers that are built on top of Elasticsearch or some of these other metric systems are generally working on much shorter time horizons and detecting whether the data is anomalous within the past few hours or days. But you could even create analyses or models for seasonal trends where, this time last year we saw this similar spike, so it's not actually anomalous from a yearly perspective, despite being anomalous within the span of the last month or so.
No, and that's a great point. Elastic has some new features like roll-ups, and when you roll things up, you lose, the texture, and you lose those patterns that may have provided that insights that the anomaly detection requires. So roll-ups are a great technique when it's too cost prohibitive. But what if you could store the data, all the data, and really index fully the data set versus subparts that you realize, oh shoot, I wish I had this attribute within the system. So we think having the real data accessible at your fingertips, as we mentioned, really opens up a lot of doors.
And you've mentioned a little bit some of the goals that you have going forward and some of the ideas that you have for the platform. So I'm wondering if there are any specific features or improvements that you're working on that you'd like to share that will sort of exhibit what you're trying to move towards in the future with Chaos Search.
Well, I'll let Pete talk to the short term, but the long term vision, we are building a data platform. It's beyond log and event data. We have a data lake philosophy with the ability to dump data into your S3 without having to worry about schema or provisioning or scale at a price point. And then from there, really be able to analyze your data in the way that you like to analyze it in a design studio. Really a database with storage, convergence is where we really want to build, be a first generation in that. But from a short-term perspective, I'll leave it to Pete for features and functions.
Yeah, I mean, in the near term, the thing that I'm finding most joy in is sitting down with people and hearing about their pain and sadness of their very expensive and very hard to manage Elasticsearch cluster, and basically going to them and saying, listen, I can give you a lot more data for a lot less money and a lot less Elasticsearch. And, a little gleam of brightness comes in these poor operators' eyes when I can, tell them that there is a future where they could actually store more data and run less servers. And so I think, my biggest goal is really just trying to find more people out there who want to go on a journey with us and try this out and give us feedback and really help us refine and make that experience as good as possible.
And one other question that just triggered is, with having these longer time spans of data, you increase the potential for having compliance issues, either because of the length of the time that the data is being stored or because at some point in the history of when you started collecting the data, you had a certain field that you've now either obfuscated or eradicated. And I'm wondering if there are any mechanisms built into Chaos Search for being able to go and retroactively modify that information, or if you would just be relying on your other ETL tools for being able to do that processing and retroactively apply these compliance regimens.
Actually, yeah, I'm glad that you asked that question. We've gotten that request a few times, and I didn't really plan for this, but Data Edge actually has the ability to wipe clean those, lack of a better term, symbols without having to re-index or transform the data. So
it's kind of the GDPR question, which is like, for a lot of companies, it's like, I got a GDPR request. I need to remove some data. And usually the first response is, well, first we have to process it all to figure out what even we have to delete it. And we started talking about this, and Thomas was like, well, we can just selectively purge that out. It's pretty easy. And I was like,
I don't have
nice.
I don't have to rebuild the indices, which is that was not intentional.
Sometimes with computers, there's happy accidents with computers.
Yeah.
We'll chalk that one.
I would say that was a free one that I got for this representation.
Most of the accidents are tragic, but occasionally they can bring joy.
Exactly.
All right. Are there any other aspects of chaos search or the problem domain that you're solving for that we didn't discuss yet, which you think we should cover before we close out the show?
No, I don't think so. I mean, I think we're really excited. I think we're onto something. There's a lot of data out there. It's growing more. For any of the listeners that want to check it out, reach out to me, check out our website. We're going to be around and out and about. So we'd love to chat more and just hear really like who's got some really interesting, unique kind of data challenges and how might we be able to help.
All right. So with that, I'll have you add your preferred contact information to the show notes for anybody who does want to follow up and keep track of what you guys are up to. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Wow, the biggest gap right now. I mean, it's we live in a golden era of open source software. I think in some cases it's good, in some cases it's not great. There's kind of thing that I see is that there's still not a lot of good stuff around kind of cleaning data up for processing, right? Like data has to get structured in a certain way, whether it's I've got log data, I need to convert it into JSON or YAML or whatever other format and stuff like that. So, and maybe it's just my inexperience in that. I haven't really found anything good from that perspective other than kind of old school Unix tools and rub a little JQ on top of it, right?
And Thomas, how about you?
I mean, we hear it is the golden age of information, and information drives value, and the ability to store more, to analyze more is important, and it changes business. It changes, our lives. So chaos search is really what we believe is a fundamental tool service that really unlocks new ideas, new businesses, and I love solving these types of problems, and hope to solve a whole bunch more as we learn about what people want to use the service for.
All right. Well, thank the both of you for taking the time out of your day for joining me and discussing the work that you're up to at Chaos Search. And it definitely looks like an interesting platform and one that I may find some of my own use with. So thank you for that. And I hope you enjoy the rest of your day.
Thank you.
Yeah, thanks a lot.